Hello guys, my name is Abhilasha and in this video lecture I'm going to cover set theory with its introduction and different types of sets. Here we are going to discuss how we can define set, what are the various representation methods and what are its different types. So first of all, how we can define a set. So it's a well-defined collection of objects. Here well-defined means we want to create a rule in which we want to decide whether a given object will belongs to that collection or not. In other words, we want to create a common behavior or common property on the basis of which we can find out that the object will belongs to that group or not. Here objects in the set, they are called the elements or the members of that set. Sets, they are generally denoted by capital letters and the elements are denoted by small letters. To denote that X is a member of set or it is a part of set A, then we can write it as X belongs to A. So here the symbol, it is called as belongs to. And if X is not an element of A, we can write it as X doesn't belongs to A. There are various ways to represent set, but the two of them are most popular one. First is the roster or tabular method. Second is set builder or rule method. As per roster or tabular method, all the elements are listed and they are separated by commas which are enclosed within a curly bracket. For example, set A, in which it has 1, 2, 3, 4, 5 as an element, are separated with the comma and we can put it in a curly bracket. Likewise, set of wall is AEIOU and it is denoted by set V. In set builder or rule method, here set is defined by specifying the property that the elements of the set they have in common. Like for example, it's a B set and where X is an element of B, where X is an even positive integer which is less than 10. There are some examples of set A. A is equals to Z. It means it consists of single element, so that is also called as a set. And if in case we have like multiple groups within a single set which are further enclosed within a curly bracket, then it is called as set of sets. If I have two elements X and Y which are put in curly bracket and further placed in a curly bracket, it means X and Y together will be a element. Here, we will not say that X belongs to A or Y belongs to A. Rather, we will call it as X, Y together belongs to A. Here, X, Y with a single bracket and X, Y with a double bracket will not be equal. P of X. Here, P of X, we want to talk about the membership function of set A. A is a set consists of X as an element where X belongs to N. It is a natural number which are greater than 7. So here the elements will start from 8, 9, 10 and up to so on. This is called as a set builder notation. There are some special sets that we generally use with our problem statements. Set of natural number, so we can represent it with the help of capital N. Set of integers as capital Z. Set of positive integers, so here superscript plus will denote this is a positive integer. Likewise, we have our rational numbers with the help of Q and set of real numbers with the help of capital R. Cardinality of a set. The number of distinct elements which are present in any set will define its cardinal number or cardinality. You can denote it with the help of N of A or with the parallel bars with the set name. For example, if we have 1, 2, 3, 4 as an element in set A, therefore the cardinality will be defined as 4. If I have B as a set of letters present in word algebra, A is repeated twice, therefore I'm going to count it once. Apart from that, L, G, E, B, R appeared once and hence the cardinality is equals to 6. If I have sets as a part of set, in that case, if 2 and 3 are together written in curly bracket and this is a part of set C, then we are going to count it as 1. Therefore, for this given example, the cardinality of set C will be 4 because 2, 3 will be counted once and 4, 5 will together counted as 1. Apart from that, 1 and 6 are the elements. If a set builder notation form is given where you have to find the cardinality, in that case, x belongs to natural number and it is less than equal to 7,000. So we can count from 1 to 7,000, therefore the cardinality will be 7,000. There are various types of set based upon the cardinality, based upon the behavior. So first one is empty. So here empty set consists of no element and therefore it is called as empty set, or it is denoted by simple blank curly bracket, or we can use symbol phi. Like for example, x is an element of any set and x square plus 1 is equals to 0, where x is a real number. So as we know that with the real number, we will never find when it is added with 1, we will get 0 in that result. Therefore, we will not get any value x which will satisfy the given condition. Therefore, the cardinality of the null sets are equals to 0. Singleton set, if we will increase the cardinality by 1, that means when we have one element within a set, it's called singleton set. So phi is empty set, but when we have phi as placed in a curly bracket, it means it is treated as now an element, and that's why this is a singleton set. Finite set. So as we know that finite set means where we have or which contains finite number of elements, where the cardinality will be a natural number, it will give me some number. That means in that case, we can say this is a finite set. Example, set of even natural numbers which are less than 200. So I'm having a specific range, and within that range, we can define its cardinality. X square, where x belongs to positive integers, and x square is less than 100. So we are having only limited numbers which comes under a perfect square. That's why within this range, it is called as a finite set. Infinite. When we say that the cardinality is infinite, you cannot count the number of elements, then the sets are said to be infinite sets, like set of positive integers. So there is no such range given, and therefore this is the infinite category. Now what the equal sets? Equal sets means when the two sets contain the same elements. If their order is different, doesn't matter, but all the elements which are present in set A are present in set B, then we used to call them equal. Equivalent sets, it is not necessary to have the elements same, rather if their cardinality is same, then we used to call them as an equivalent set. Like for example, set A consists 1 to 6 and set B consists 16, 17 and 22. In that case, the cardinality of both the sets is equals to 3. Therefore, A and B are called as equivalent sets. Overlapping sets. Here two sets, they have at least one common element, and therefore we can say they are overlapped with each other. Now, based on this overlapped set, we can follow the different properties, and you will find these properties when we are going to discuss the inclusion-exclusion principle in this case. Like for example, a set A is given with 1 to 6, set B is given with 6, 12 and 42. There is a common element 6. Hence we can say A and B are overlapped sets. Disjoint sets, when you do not find any common element within the two sets, then they are said to be disjoint. And with respect to disjoint sets, properties followed as the cardinality between the common elements will be 0, or it is a null set, and you have number of elements which are present in set A and set B will define the total cardinality of union. Here, set A will consist of 1 to 6 and set B consists of 7, 9 and 14. As you can see that none of the element is common between these two, therefore they are called as disjoint sets. Subset. So what is a subset? Subset means it's a part. It's a part of any set. Like for example, a 1, 2, 3 together will be called as a set and given as a set 1. But I have taken only one specific element from that and will place in another set, and therefore we can say that 1 is a subset of 1 to 3. Like this 1 to 3, since all the elements are there, of this set into the another one, therefore we can say it is a subset. So in short, we can say that set A is said to be a subset of B if and only if every element of A is also an element of B. When we talk about superset, so superset A is a superset A is a subset of B, right? Then B will be called as a superset because that is a parent set to which we are mapping. Any subset of set B is called as a proper subset when there is at least one element of B which doesn't belong to A. It means if I don't have or I don't have possibility that two sets will be equal in any manner, then we used to call it as a proper subset. Like for example, AB and ABC. So as you can see that some of element of set B is not present in set A. So superset is having some elements which are not having in this child set. Therefore, 1, 2 and 1, 2, if I'll say, then that will be a subset, but not a proper subset. So for every set S, null set will be a subset of S and every set is a subset of itself. So these are the two properties that are fulfilled by every set. For three sets, if we say, if I have A is a subset of B, B is a subset of C, then A is also a subset of C. Power set. Set of all subsets of a given set is called as power set of A. And you can denote it as P of A. Here, every element is a set. If A has n elements, then its power set will consist of 2 raised to power n elements. If the cardinality of set A will be n, then the cardinality of its power set will be 2 raised to power n. Like for example, for a set A, the power set will be phi because phi is a subset of every set. We have already seen this property, and A will also be a subset of this. Since we are not talking about proper subset, we are only considering the subsets. That's why in its power set, single element A is going to be considered. Now B is having 2 elements. In that case, you will find that the power set will consist of 4 elements because in this property, we have already seen that if n elements are there in set, then its power set will consist of 2 raised to power n elements. Therefore, it will consist of 4 elements. Now, how you will define power set in case of 2? Phi is a subset of every set. Element A will be there. Element B will be there for the subset, and then AB together because it's a subset. Set is a subset of every set. For example, 3 elements are given with any set C and you have to define its power set. Then how you will define it? That the power set will consist of phi. A will be a single element, B as a single element, C as a single element. Then we can have a pair of 2 like AB, AC and BC, and set ABC will be a subset of itself. That's why it is also included. In short, if there are 3 elements, that means in its power set, we should have 8 elements, as you can see. Now, if let's suppose B is given where X and Y, this is a curly bracket here we have used, then in power set, the element Y along with the curly bracket will be considered as an element. So whenever you are going to place it, whenever you are going to define its power set, then you have to use this Y along with its curly bracket will be one element. And therefore, the power set of B will be defined as phi, X, Y, X and Y. But Y will always be there with its curly bracket. Likewise, for the set E, where I'm going to have X and Y as a subset which is present, and therefore 2 elements will be considered because the cardinality is 2 of E, and therefore the power set will consist of 4 elements. And as you can see that X and Y here will be together placed wherever we are going to consider this as an element. Now we have to find the value of n, P of phi. So how you are going to find it? That the power set of phi, since empty set is there, so empty set, in case of empty set also, we are going to have phi as a subset. Therefore, the power set of phi will be phi as an element. So here I'm going to have one element in that case. Then in second power set, when we are going to apply the power set of phi, then again, since power set of phi is having a phi element, now this is considered as an element, and therefore in the next one we are going to consider it as, you can see that we are going to take it as another element. So here this is going to be one element. Now for the second one, since it is the cardinality of this power set is 1, now we are going to find its power set. Therefore the cardinality will be 2 ki power 1, that is 2 raised to power 1 will be 2. So phi is a subset of every set, and this phi will be then element. Like this, when we are going to have the next one, when you have to apply the power set for the next element, that means now the cardinality of, that is the cardinality of P of phi is equivalent to 2. So when we are going to apply its power set, then the cardinality should be 4. So here, when we are going to define, so how many elements are there? 2 elements. So phi will be a subset of every set. So this is actually a phi, and this is an element phi, which is this one. This is an element phi, this one. And like this complete set will also be a subset. Similarly, when we are going to apply it next 4th time, right? So how many elements are going to be there? As you can see, total 4 elements are going to be there. Therefore, we are going to write it as 4. Therefore, the cardinality will be equivalent to 4. And hence we will got the answer 4. So this is very simple, and you need to take care of the thing that in which respect we are talking about. Second, it's universal set. So it's nothing but we can say for a given content, for a given collection, if I consider all the elements in a set, it is called as a universal set. And whenever you will find capital U written anywhere, it will be a universal set. So for example, for A, B, and C together, if I consider that can be a natural number, which can be from 1 to 10, 1 to 7, or any other one. So thank you for the same. And we will see different operators which can be applied over set in our next lecture. So thank you.